All right, this is the free response question on our practice test. A pollster conducts a survey in the eastern U.S. to determine the percentage of American adults from this area that approve of our current president. The results of the survey show that 629 of the 1,000 participants approve. Part A, construct a 95% confidence interval for the proportion of American adults in the eastern U.S. that approve of our current president. All right, so first I'm going to make a couple notes. So first, the sample size is 1,000. The proportion of the sample that approve is it'll be 0.629, right? 629 divided by 1,000 would be 0.629. Okay. And then the critical value that we're going to use, because it says 95%, that's going to be 1.96. 1.96. Yeah. Now, notice that there's just like this big empty space on the page because they want us to write a structured response. Okay. And so that structured response is going to follow what we call the 4C method, right? So first we're going to choose the correct inference procedure. We're going to check the conditions. Then we will calculate the interval, and then we will write a conclusion in context. Okay. All right, so this problem, it looks like they are just sampling from one population and they're trying to estimate a parameter. So this is going to be the one sample Z interval for P, right? We're trying to estimate a true proportion. All right, we might want to define P here, right? So the parameter is the true proportion of all American adults in the eastern U.S. that approve of our current president. All right, let's see, why don't I just try to fit that all in one line. Maybe not all of it in one line. Okay, cool. All right, next, let's check our conditions. So first, the random condition. All right, so it says here, oh, does it say? Pollster conducts a survey in the eastern U.S. Oh, it doesn't say whether it was a random sample or not. That's odd. Okay, I think we will just make the assumption that it was a random sample. Okay. All right, assume random sample. Okay. All right, next is the 10% condition. Okay, so there were 1,000 adults in the sample, which is likely to be less than 10% of all American adults in the eastern U.S. Okay. All right, lastly is the large counts condition. So we're going to do 1,000 times 0.629, which of course is 629. That's greater than or equal to 10. And then we'll do 1,000 times 1 minus 0.629, which should come out to 371. And that's also greater than or equal to 10. All right, So what we were doing there was n times p hat and n times 1 minus p hat. And each of those, according to the condition, must be at least 10. All right, so everything's met with kind of a tiny assumption that we made. Again, I'm still surprised that the question stem did not specify whether the sample was random or not. That's, yeah. All right, now we're going to calculate the interval. So I always like to start with the general formula, point estimate plus or minus the margin of error. And then it's always a good idea to write out the specific formula. Okay, so I'm going to refer to the formula sheet because a lot of people don't memorize it. Okay, right. So here's our point estimate, right? P hat. Okay, the margin of error is the critical value times the standard error, which again we can look here. Yep, in this column here, standard error. Square root p hat 1 minus p hat over n. Okay, so we've got both the general and the specific formula written down. Next, we're going to plug the numbers into the formula. Okay. I'll do it over here. So 0.629 plus or minus 1.96 times the square root of 0.629, 1 minus 0.629, all over 1,000. Okay, and then lastly, we will write out the endpoints of the interval. And so now here's where you finally get to plug all those nice numbers into the calculator. All right, so the left endpoint is 0.599. And the right endpoint is 0.659. The last thing to do here is to write a conclusion. So I'll write out the template and then I'll fill in the details. So we are blank percent confident that the interval from blank to blank captures the true blank. All right. So the first thing is the level of confidence, which is 95%. The next two are the interval itself. So 0.599, which is roughly 60%, to 0.659, which is about 66%. And then the last one is the context. Okay, the context is the proportion of all American adults in the eastern U.S. that approve of the current president. True proportion of all American adults in eastern U.S. that approve of our current president. All right. So you can see here that this response is only like, I don't know, 25% math, 75% writing, okay? Which a lot of students don't realize when they sign up for AP Stats. They don't realize how much reading and writing is involved. It's not just a math class. Okay, anyways, let's move on to part B. Shortly thereafter, a similar study is conducted in the western U.S. with the intention of constructing a 95% confidence interval for the proportion of adults from the western U.S. that approve of our current president. What is the smallest sample size that can be used to guarantee that the margin of error will be less than or equal to 0.01? Okay. So we want a margin of error equal to 0.01 or less, but equal to 0.01 with 95% confidence, so meaning our critical value will still be 1.96. Okay. All right, so the margin of error formula is, it's this part right here. I'll just copy it. So that's the margin of error. It's the critical value times the standard error. Okay. Now, there's a couple ways we can go about this. Okay, option number one, well, so no matter what method we choose, right, we're going to be substituting 0.01 for ME, 1.96 for the z-score. The sample size, that's what we're trying to solve for. Okay, so here's our options. Option number one, right, for p hat, we could use the one we got from the first sample, which was from the eastern US. Okay. Option number two is we could disregard this, and one reason why we might disregard it is because we might feel that people on the West Coast might have different feelings about the president than people on the East Coast. So it might not make sense to use this estimate for the West Coast. It's completely different populations we're talking about now. Okay. So if we feel that way, then we're just going to use 0.5 for the sample proportion. Okay. All right, that's what I'm going to propose. All right, is that we don't assume that the West Coast is going to be similar in their behavior and their feelings towards the president as the East Coast was. So we won't assume that value there. Okay. So we'll do 0.01 equals 1.96 times the square root of 0.5 times 0.5 over n. Okay. All right, now to make life a little bit easier, we're going to take that big square root and we'll separate it into two smaller square roots. And by the way, if we're simplifying, right, 0.5 times itself is equivalent to 0.5 squared, which means now we can essentially get rid of this square root and that power. Right? They're just inverse operations, and now we just have that. Let's clean this up just a little bit. All right, so let's multiply both sides by root n, and we can divide by 0.01. Okay. So 0.01s cancel on the left, the root n's cancel on the right, so now we've got the square root of n is equal to 1.96 times 0.5 divided by 0.01, and then now we'll square both sides. Okay, so n is equal to, all right, so I'll do this part on the calculator. 1.96 times 0.5 over 0.01 all squared is 9,604. All right, so they've got to take quite a big sample, right? Over 9,600 adults in order for the estimate to be within 1% of the truth with a fairly high level of confidence. Now, if you're curious, you know, what would we have gotten had we used this value instead? Okay, well, I don't know, I'm kind of curious. Let's see what it would have been. Let's move that. Let's move that. Okay, so had we done it the other way, we would have had 0.01 equals 1.96 times the square root of, what was that value? 629. 629 times 0.371 divided by n. Okay. So I still would have done the same thing. I would have taken that big root and written it as two roots. Okay, I wouldn't have been able to simplify like I did before. So now we would just multiply both sides by root n, still divide by 0.01, cancel, 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 cancel. So root n is going to equal 1.96 times the square root of 0.629 times 0.371 divided by 0.01. Okay. And then we would square both sides. Okay. So on the left-hand side, right, the square and the square root cancel each other out. On the right-hand side, we would distribute the power, right? Distribute it to the numerator, distribute it to the denominator, and distribute it to the radical. So we would have 1.96 squared, 0.01 squared, and the root of 629 times 371 squared. Okay, now we can simplify the root and the radical and the power there. They are inverse operations. And then we'll do this last calculation. 1.96 squared over 0.01 squared times 0.629 times 0.371, giving us 8,964.7, which, since we have to sample people, that'd be 8,965 people. So between the two options, right, this one's what we call a little bit more conservative, right? It says, okay, sample more people. This one is less conservative. But again, I wouldn't take this approach because this approach assumes that people on the West Coast and East Coast have similar feelings, which I wouldn't want to jump to that assumption. So just do the conservative approach.